Alright guys, so here's my video on using Pythagorean theorem to solve word problems. Our goal today is we're going to be able to solve real-world problems using the Pythagorean theorem. Because now that we've gotten a little bit more comfortable with it, we're going to be able to do some questions like this. There's a lot of problems in real life dealing with the Pythagorean theorem because there are a lot of right angles in real life. Hopefully you know by now that you need a right angle for the Pythagorean theorem to work, or you haven't been paying attention at all this chapter. The hardest thing for today is figuring out what side A, B, and C are all going to be. Now typically we say C is the largest, but if one of the side lengths is missing, you're not going to be sure which one the largest is. So the thing I want you to remember even more than the largest is remember that C is the hypotenuse, or the side that is across from the right angle. This is going to be even more important than the largest side. Now a big thing for today is when they don't give you a picture, just draw one yourself. So let's do one together right here. Example 1 says a 20-foot ladder is being leaned up against a wall. If the base of the ladder is 8 feet from the wall, how high up the wall will the ladder reach? So you guys please draw this picture along with me and we can do this one together. Now before we do anything, I have this little sentence right here. Remember to solve for the variable, not the variable squared. Remember that last step is going to be to take the square root of both sides. So I'm going to draw my wall, the top of it even, and a 20-foot ladder is being leaned up against this wall. Here's 20 feet of ladder. Boom, 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 boom. 20 feet. It says if the base of the ladder is 8 feet from the wall, so that 8 feet from the wall tells us not how tall the wall is, but it tells us this distance right here. So hopefully by now you guys can see the right triangle in here. Here's my right angle, and here's the rest of the triangle. So what we're going to do is we're going to find out how tall or how high up the ladder, how high up the wall the ladder will reach. So let's do that. First thing, let's write down our formula. A squared plus B squared equals C squared. And the most important thing to do is to figure out whether that 20 is a B or a C. Because the right angle is being pointed right at the 20, that means that 20 is our C. So something is going to be equal to 20 squared. And that's going to be 8 squared plus B squared. That will be this side. In order to help us with this, I'm going to use my calculator. Hopefully you guys have yours with you. And let's figure out what 8 squared and 20 squared is. Well, 8 squared is pretty easy. That's just 64. Plus B squared is 20 squared is a little bit tougher. Some of you might already know what it is. Times 20. And I end up getting 400. So B is not all by itself yet. Remember, we're just solving an equation. Let's subtract 64 from both sides. 400 minus 64 is 336. But again, this is where this sentence comes into play. I want the variable, not the variable squared. Obviously, this height is not 336. What I have to do now is take the square root of 336, which on my calculator, it's right here. You guys will have to hit a different button that we've already reviewed. And I'm going to get 18.3 junk. I'm just going to round it off to 18.3 feet. Okay? So B, or the height of the wall, is equal to 18.3 feet. All right? That's it. So it's really nothing new. It's everything that we've been doing, but we just had to draw our own picture. The next example I really, really like. It's hard to find the triangle here, but I did start to draw the picture a little bit for you. So example 2, Robinson Cano is one of the best second basemen in all of pro baseball. Not only is he one of the best hitters, but he's also one of the best fielders in the game, even though second base is not the easiest position. Now the reason I say that is if he was standing right on second base, he has the farthest throw it out of anyone else in the infield because he'd have to go all the way down here to home plate. From first base to home, it's only 90, and from third base to home, it's only So what we're going to do today is we're going to see how far does he have to throw the ball to reach home plate. Now, he could go the long way. He could throw it to first. That would take 90 feet. And then first baseman could throw it home, and that would take another 90 feet. Not degrees, feet. And 90 feet. And that would be 180 feet. But if he threw straight home, obviously it's going to be a little bit shorter. So let's figure out how much shorter it's going to be. Now, just like before, the most important thing is that you figure out where the right angle is. So is this the right angle, that the right angle, or is that the right angle? I think it's pretty obvious which one it is. That one's our right angle, and it is pointing to this side, which means that this side has to be our C. So my equation is going to be 90 squared plus another 90 squared is equal to C squared. Now 90 squared is going to be large, which is going to be 90 squared. 8100 or 8,100. 8100 plus, well, this one obviously has to be 8,100 as well, is equal to C squared. And let's add up two 8,100s, or times it by 2. And I get 16,200 is equal to C squared. But again, I don't really want C squared. I want the square root of that. So let's take the square root of both sides, and I end up getting C is equal to whatever the square root of 16,200 is, which on my calculator says it is 127.3. Or does it ask to the nearest foot? No. So I'm going to just say 127.3. Okay? And that's it, guys. There's another real-world example that we did. I would like you guys to try some. I have two questions right here. So pause the video, try these two, unpause it, and you can test how you did. So let's try that right now. All right, so let's do number one together. It says to get to from point A to point B, you must avoid walking through the pond. To avoid walking through the pond, you must walk 34 meters south and 41 east. The nearest meter, how many meters would be saved if it were possible to walk through the pond? Now, this is definitely a type of question that's going to be asked on your test. Because I'm sure a lot of you guys were able to get the answer to what the question mark was here, but you didn't really answer the question. And I'll explain that after we figure out what the question mark is. Just like for these first two questions, the most important thing is that you figure out, are we trying to find A, B, or C? Well, let's find our 90-degree angle. I see it right here. And it's pointing to the question mark. So the thing that I do not know is C. So when I plug into A squared plus B squared equals C squared, I'm going to go 34 squared plus 41 squared is equal to C squared. And then I'm going to go through all these calculations. 34 squared is 1156 plus 41 squared, 1681 is equal to C squared. I'm going to add up these two. Plus 1156. And I'm getting 2,837. So 2,837 is equal to C squared. To find just straight up C, though, remember, I need to square root both sides, and I end up getting 53.2. But it wants it to the nearest meter, so let's call it 53. And let me get back to what I was saying before. So I'm sure a lot of you guys have this. Now, if this question asked, how far would it be to walk through the pond? We would have answered this question. But it says, how many meters would be saved if it were possible to walk through the pond? So it was 53 meters from there to there. How far was it to go from A to this point to B? Well, I just have to add up 41 and 34. And I end up getting 75. So 75 minus 53, I ended up saving 22 meters, which is pretty good. Okay? So I'm sure a lot of you guys didn't have that. Don't worry if you didn't. That's okay. Hopefully you have it now, so I'm giving you time to write it. And let's see how you did in the next one. Firefighters have a 17-foot extension ladder. In order to reach 15 feet up a building, how far away from the building should the foot of the ladder be placed? So let's draw this picture. We have a building. We want a ladder to go up on this building. It says have a 17-foot extension ladder. So the ladder itself is 17 feet. We want to reach 15 feet up the building. We want to be right here is 15. So it wants us to figure out how far away from the building should the foot of the ladder be placed. It wants us to figure out this blue line. So hopefully you guys are able to at least draw that picture and find the right angle. Where's the right angle, obviously? Where the building meets the ground. So, is that 17 a C? A B? What do you think? Well, hopefully you thought it was a C because the right angle is being pointed at it. So when I plug into a squared plus b squared is equal to c squared, I'm going to plug in 17 in for my c. And it really doesn't matter where that 15 goes. You could plug it into the a squared or the b squared. We really don't know which one the smaller one is yet. I'm going to plug it into the b squared. I think it's a little bit bigger. So let's solve this now. A squared plus 15 squared, no idea. 225 is equal to 17 squared, 289. Now obviously all I'm doing is solving an equation, so let's drop our line down. Subtract 225 from both sides. A squared is equal to, it might be faster just for me to do the math right here, 4 and 6. Oh, so if a squared is 64, what is just straight up a? What times itself gets me 64? 8. All good? And that's it, guys. So hopefully you did pretty good on both of those questions. Before we start our homework, let's do some final thoughts. There are a lot of real-world Pythagorean theorem problems because there are a lot of what type of angles in real life? Right angles. The Pythagorean theorem is a squared plus b squared is equal to c squared, where a is the small side, it's the first side, and c is the biggest. To undo squaring, you take the square root. It's the opposite, sort of just like multiplying and dividing. When solving Pythagorean theorem problems, you're solving an equation. That's it. We did equations this whole year. You should not have a hard time with that. So the rules for solving so use the rules for solving an equation. And last but not least, most real life problems will not be perfect squares. What I mean by that is this problem right here. It took 8 feet for this ladder, but more than likely it's not always going to be that nice. More than likely it's going to be more like this question right here where it was 53 point something, or this one right here where it was 127.3 feet to throw from second to home. All right, guys, that's it. Thank you for watching.